Okay. 8.3, calling geometric. Last week, guys, whenever I saw you, if I say yesterday, you know what I mean. We talked about arithmetic. That was when, if you had a graph, it was going to be a line. And if we talked about the common difference and all that stuff, that was going to be what you added or subtracted every time. Geometric, if you graph it, it's going to be an exponential graph. Remember what those look like? Like a smooth curve.
Yep.
And it's when you multiply something every time. The same thing every time. It's always multiplication. So geometric is multiplication. Instead of the common difference, they call it the common ratio. All right. So same kind of concept, just different wording. Geometric is multiplication and it's ratio. When I say multiplication, I want you guys to understand that, because if I go from 24 to 12 to 6 to 3, and I say, okay, guys, what's the common ratio? What are you multiplying by every time to get to the next number?
2.
Not 2.
1/2.
Oh, itself?
Because you're dividing by 2, right?
Oh, half, right.
But when we talk about our geometric sequences and series, we only talk about multiplication. So whenever you're going downwards, whenever you're dividing, you're really multiplying by fractions. So your common ratio here would be 1/2. I just want you guys to see that. So if you look here, right, and that you get this sequence and or series, and they say, what's the common ratio? Well, what are you doing to each number to get to the next one? How did you get from 2 to 4 to 8 to 16? If I said to you, is this arithmetic? You would tell me no, because if it's arithmetic, you're going to add or subtract the same number every time. Here, you're not adding or subtracting the same number every time. You're multiplying. Everybody see that? 2 times 2 is 4, times 2 is 8, times 2 is 16. So your common ratio here would be 2. Here, how'd you get from 12 to 16? 12, 36, 108, 324. You're multiplying by 3 every time. So your R would be 3. If you notice, guys, with geometric, the numbers get bigger a lot faster. Because when you multiply, the numbers become larger much quicker than if you just add the same thing every time. Now, you guys are going to get numbers sometimes that are huge, and you're like, well, how am I supposed to know what the common ratio is? How did I get from this number to the next? All you have to do is take a term in the sequence. So if I take 108, right, this term right here, divide it by the term in front of it. What's 108 divided by 36?
3.
What's 324 divided by the term in front of it? 108. 3. That'll give you can do that every time. So especially if you get something like this, you're like, ooh, fractions. Well, most of us would see how you go 3, 9, 27 has something to do with 3, correct? But if you're not 100% sure, just take negative 1/27 divided by 1/9. You can do that in your calculator. You can do it in your head. You can say negative 1/27, negative 27 times 9 over 1, right? If you change flip, you get negative 1/3. If you notice, when your common ratio is negative, your signs will alternate. See how we go negative, positive, negative, positive? Because when you multiply by a negative number, negative times a negative is a positive. Then when you multiply it by a negative, it becomes negative. Then it becomes positive. So whenever the ratio or whenever your sequence goes negative, positive, you know your ratio is going to be negative because it's alternating. So let's do a couple of examples. There's a couple of these that are going to feel like a little like, what? This is kind of hard. It's really not. You'll be okay. But here is your geometric formula. All right, when we had arithmetic, it was a sub n equals a sub 1 plus n minus 1 times d, right? You just plug that in. This is your geometric formula. A sub 1 is the first term. R is your ratio, whatever they tell you it is. And then n is, again, your term number. It's really important that you guys remember in the formula it's n minus 1. So if you have a question like this, super simple. If it says find the first 5 terms, well, you got to find the rule first. So a sub n equals, what is the first term? 3 times my ratio is what?
2.
2, right? And then n minus 1. That's my rule. So to find the first 5 terms, you would plug in 1, 2, 3, 4, and 5 for n. So to show me that, you guys would say a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So you'd have 3 times 2, and then 1 minus 1. Y'all see that? So you have 3 times 2 to the 2 minus 1. 3 times 2 to the 3 minus 1. 3 times 2, 4 minus 1. And then 3 times 2 to the 5 minus 1. Now, it's important, guys, that you remember your order of operations. You can do this in your calculator. You can put it in just like that. You can simplify it. You can say this is 3 times 2 to the 0. This is 3 times 2 to the 1. 3 times 2 to the 2. 3 times 2 to the 3rd. And 3 times 2 to the 4th, right? But remember, guys, you're raising to the power, then multiplying by 3. It's not 6 to the 0 power, then 6 to the first power, 6 to the second. So when I do this, 2 to the first power is 1, right? So this is 3. I mean, it's 2 to the 0 power, I'm sorry. 2 to the first power is 2, so 2 times 3 is 6. 2 to the second power is 4, so 4 times 3 is 12. 2 to the third power is 8, so 3 times 8 is 24. And then this is 16, so this would be 48. Everybody with me? We okay?
Yeah.
All right.
Yep.
Okay, so let's look here. Same concept. It says find the 15th term. Well, here in this case, they tell you that a sub 1 is 20, right? First term. They tell me your common ratio is 1.05. I want to know the 15th term. So plug in your formula. A sub 15, the first term is 20 times, what is your ratio? 1.05. And I'm going to raise that to the 15 minus 1. So this is 20 times 1.05 to the 14th power. And in your calculator, you can put it in just like that. 20 parenthesis 1.05 and then raise that to the 14th power. So the 15th term is about what? What'd y'all got? Anybody?
I don't have my calculator at the moment.
Anybody do it?
39.59.
Perfect. Questions? We feel okay?
I need to get my calculator.
Okay. Anybody have questions though? We're all right? Okay.
I've redeemed myself.
Okay, no problem. Now, guys, they're telling you all the information you need to know, just giving you the sequence of numbers. Because remember, this is our formula. I'm trying to find the 9th term here. So if I want to find the 9th term, what is a sub 1? What's my first term?
5.
That's 5, right? So a sub 1 is 5. Times, what's the common ratio? How did I get from 5 to 15 to 45?
Multiplied by 3.
Yep, because look, take a term, divide it by the one in front of it. It's 3. Take another term, 45, divided by the one in front of it. It's 3. So your common ratio is 3. And then I'm going to raise that with the 9th power, so to the 9 minus 1. So a sub 9 equals 5 times 3 to the 8th power, correct? What's the 9th term? Do that in your calculator. What's 5 times 3 to the 8th power? You got to raise it to the 8th power first and then multiply it by 5.
32,805.
32,805. It is a big number. Remember, I told you with exponentials, with geometric, which is exponentials, the numbers get big in a hurry and they get small in a hurry. Okay, we all right?
Yep.
Okay, next question. This on the teacher copy, and you'll see it in a second. I can show you at the end here. I took a snapshot or a screenshot of what the book, how the book explains it. But we had a question like this in our last lesson. Like I told you, the 4th term was 16, whatever. Then the 20th term was 100. Now, this won't make sense because I didn't add it up. But what did we do? What was the first thing we did when they gave us 2 terms and they want us to write the rule? Do you guys remember? We figured out how far away these 2 terms were. We said,
so
this is
you would
16
take the number of spaces, right?
away. Okay, that's the same concept here. They're telling me that the fourth term, so a sub 4, is 125, right? And they're telling me that the 10th term is 125 over 64. You guys agree with me? Right? Isn't that what that says?
Yes.
Okay, so how many spaces away are these two terms?
6 spaces.
6 spaces. They're 6 spaces away. So when we did this with the arithmetic, we said, okay, well, the 20th term, we put it out here, equals, and then we said it was this term plus whatever, how many spaces was, right? And then, because we're trying to find the common difference. This is our arithmetic. That's not even close to how you spell arithmetic, but you guys know what I mean. So we're going to do the same thing here. We're going to say, okay, the 10th term equals the 4th term, right? Times our ratio to however many spaces it is. We're not multiplying together in this one like we did over here. Over here, we're going to raise it to a power because geometric has our powers in it. So fill in this information. The 10th term is 125 over 64. The 4th term is 125. And then I have r to the 6th because we're trying to figure out what that r is. Now, again, this, I understand, this seems a little like, wait, huh? That's okay. The more we do this, and again, we have 2 more class periods next week to practice this. The more we do this, the easier it'll get. But I'm trying to isolate r to the 6th. Correct?
You have to divide.
Okay, so I'm going to divide both sides by 125. So I have 125 over 64 divided by 125. That's a fraction divided by a fraction. So I'm going to say keep, right?
Change food.
What am I changing this to? Multiplication?
25 over 1.
Wouldn't that just be
125 over 1.
It's going to be 1 over... Yes, I'm sorry. My bad. It's going to be...
Yeah, wouldn't it just be 1 over 64? Because
well, yeah, because watch what happens. I'm going to do 1 over 25, right? 125. What happens to my 125s?
They cancel
They
out.
cancel out. So I have 1/64 equals r to the 6th. Now, I don't want r to the 6th. I want just plain r. So what would I do?
You do the root.
Yep.
You
6th root. If I do the 6th root on one side, I do it on the other. So r equals. Guys, what number times itself 6 times gives me 1? 1.
Number times itself 6 times is 1.
What number times itself 6 times gives me 1? Just 1. What number times itself 6 times gives me 64?
16?
6.
No, smaller.
Yeah. You're on the right track. Real small.
It was 8.
Smaller.
Small.
8 times itself 6 times, not going to give you 64.
Oh.
8 times the 8 is 64. Well, 1 times itself 6 times gives me 1. What's 2 to the 6th power?
64.
Yeah. So you guys just figured out there the common ratio is 1/2. So in order to write my rule, I need the first term, my common ratio, to n minus 1, right? Yes?
Yep.
Mm-hmm.
So you could work backwards from here. Or you could take the information that they gave you, all right? Let's look at the information they gave us. I want to find the 14th term. I don't know what it is, do I? Trying to find out. But what 2 terms do I know?
The 4th and the 10th.
4th and the 10th. Okay, so I know 2 of those. I'm going to use I'm going to use the 10th term because it's closer to the 14th one. You could use the 4th and do the same process. But I'm going to use the 10th term. And I'm going to times it by the ratio. And remember, you're trying to find the 14th term. Well, if we're starting at the 10th, how many spaces away are we from the 14th? 4
spaces.
So that's where that goes. So all you're doing is to find the common ratio. You use the 2 terms that they gave you. And then to find the one that's missing, you have to, again, count spaces. But when I do this, I don't know what a to the 14th is, but I know the 10th is 125 over 64, right? What did I figure out my common ratio was? 1/2.
Half.
And I got to go 4 more spaces, so that's why I'm using to the 4th. So if I simplify this, guys, I get 125 over 64 times, what's 1 to the 4th power?
1.
1.
What is 2 to the 4th power?
16.
16. And just simplify that. Keep it as a fraction. Multiply across. 125 over, what's 64 and 16? 1024?
4.
10, 24.
Oh, sorry. Multiplied. Well,
So, the 14th term is 125 over, that's it. That is it. Again, I know that sounds a little like, wait, what? Huh? It's okay. The more you do this, you'll be okay. I promise. Promise, promise, promise. We're right there? Okay.
Yep.
Good.
Yep.
Good talk, guys. Good talk. All right, we're going to talk about the sum of finite and geometric sequences. Sum means what? Add.
Addition.
Okay, so you got to find all these terms, and you're going to add them together. Finite. What does finite mean?
not
It
infinite.
ends.
It ends, okay? So when you have a finite something, it ends. What you guys need to understand here is when I talk about a sub 1 in a finite, and again, you'll have this in front of you when you take your test or quiz, because I'll let you guys use your notes, but this includes the ratio. Okay? N is the term number you're looking for. And R is your ratio. Okay? You'll see what I mean by that in a second. So in this example...
Wait. Go back for a second so I can write.
Oh, I'll write it right here.
Yeah.
I'm sorry. In a finite series, when you fill in this part, the a sub 1, it's including the first term. So the hardest thing about this is just actually how you put this in your calculator, because you have this information in front of you. But in this case, what is the first term including the ratio?
1.
No. Look at your formula. What is the first term? That's the first number you want to plug
sorry.
in. And I'll explain to you what I mean by that in a second. But looking at the ratio, what's the first term? Well, I mean, looking at the problem, what's the first term including the ratio? 4 times 0.3, right?
Yeah.
Okay, so then I have 1 minus, what's the ratio by itself?
By itself?
Mm-hmm. What's just the ratio? What's in the parentheses?
0.3.
Yep. And then what's the ending number? What do they want me to end with?
12.
12.
Yep, that's the term. And then over 1 minus the ratio again, 0.3. You guys see that?
Yeah.
Okay. Putting this in your calculator is the hardest part. If I were you, I would do it like this. Okay. You could do it this way if you wanted to. You could plug in starting with 1 and then what?
Ending with 12.
Ending with 12. You could plug that in for n every single time and then add them all together. Or you can use this formula. Doesn't matter. But you could do 4 times 0.3 to the 1, 4 times 0.3 to the 2, 4 times 0.3 to the 3, 4 times 0.3 to the 4, and then add all those up. But when it's geometric, it becomes really tedious. So I wouldn't spend too much. There is a shortcut, to a workaround if you wanted to do that. Now, when we have an infinite, this is real easy. How do you know this one is infinite?
It has an infinity
It's
sign.
got an infinity sign, okay? In this case, this is the first term. It does not include the ratio. It's just the number that's at the beginning. And then R is your ratio. So this, guys, is a very simple formula. Your A sub 1 is just the first term, doesn't include the ratio. And then the R is just the ratio. So for these two questions, let's do these two and then we're done. Is this infinite or is this finite?
Infinite.
It's infinite because there's an infinity sign at the top, right?
Yep.
So my formula is as follows. The first term, not including the ratio, so literally just the first number is what?
4.
4.
Oh, 4.
Over 1 minus the ratio. Well, what's the ratio?
0.6.
0.6. So in your calculator, you do it two ways. You can either say 4 over 0.4, right? Or if you did it in your calculator, you'd have to put this in parentheses to make sure. But what is the answer here?
10.
Mm-hmm. That's it. Same thing here. Look at B. You need the first term and you need the ratio. Well, what is the first term?
3.
The first
Oh,
term is
3.
3, right? Do they give you, how do you know, first of all, before I even start, I'm sorry, how do you know that this is an infinite and it's not finite?
Well, because there's the ellipses at the end.
The ellipses at the end. These 3 dots mean this goes on forever. So in order to find what's happening every single time, take one of the terms in the sequence or series and divide it by the one in front of it. So I'm going to take 0.03 and I'm going to divide it by the one in front of it, which is 0.3. What do I get?
Oh, 0.1.
Yep, 0.1. So my R is 0.1. So I literally will say 3 over 1 minus 0.1. Do that in your calculator. 3 minus 1 minus 0.1.
3.3 repeating.
Yep. It's 3.3333, something like that. Make sense?
Uh-huh.
Yeah.
Okay. That's it.